I'm Peter Burkholder. I'm a platform engineer and custom engineer with cloud.gov, and I'm also here with today is James Scott, who's also in the customer squad, who will be helping out online and in person. So I'm going to launch into my thesis, which is that I want you to use cloud.gov, and there are 4 reasons that motivate me to work for cloud.gov and to bring this to the federal government and the American people, and I want them to be your passion too. The first is that cloud.gov enables a focus on mission like nothing else available to the federal government, and at a total cost of ownership that is below most, if not any other option. Focus on mission and a focus on eliminating the long lead times that we've become far too accustomed to in building and provisioning federal IT services. Since 2009, I've been a student of and advocate for the DevOps movement, which is the idea from the private sector that we need to shorten the lead time from aha to ka-ching. Well, there's no ka-ching as such in our work, but there is mission realization. And the main tenet of the DevOps movement is that we need to bring development processes to operations teams, such as using version control, testing, and automation to their work. And we need to bring operational awareness to developers and engineers. So when they're coding, they are thinking about how does this scale, how is it monitored, how do I get logs back, and how do I engineer for reliability. More importantly, this cuts across teams, and by breaking down silos between development, operations, security, and QA, not only do you move faster, but by continually releasing in small, well-tested batches, you have better reliability and better security. And this has been very well demonstrated in numerous surveys of practice. And most importantly to me, it makes for a more sane and humane workplace when people can work office hours instead of staying up late for heroic releases. So focus on mission, eliminate long lead times, and provide stewardship of tax dollars. There's about $85 billion a year in civilian IT spend, and only 8.2% of that is classified as provisioned or cloud services, that it is actually reusing a system that someone else has built. We are not seeing a whole lot of value from that, and particularly with the prospect of cuts in particular programs, is really a time to focus on how to get the best value out of that dollar and provide the best stewardship of taxpayer money. And lastly, a sense of patriotism that we should provide great public services that are easy to use, that are responsive, and that are updated to suit changing needs, and to be an example to the world. What we have built in cloud.gov is open source, and we have already seen our work picked up by the UK Office of Digital Services in Australia, as well as federal and or state and local governments. And this is something that is a benefit more broadly, as well as us being able to pull back some of their contributions in. So how does cloud.gov do this? Well, we do this by thinking about your mission. The mission that you might have at your particular agency, that you have a goal to serve. For an example, if you're with perhaps FEMA, HUD, or VA, you may be thinking a lot these days about housing for disaster victims. How do you match up need for housing with available housing? At this point, you may already have a team eager to get to work, some mix of project managers or product managers, designers and engineers and developers, operations and security. What are they going to need to actually realize this mission is a platform where they can build the service, where they can test it, and they can run it. Now, when I say a platform, there's a number of different components that make up a platform where you can build, test, and run an IT service. You have a technology stack, say a web server like Nginx or IIS, an application server like JBoss or Python Django, a database, Oracle, Postgres, SQL Server. You may need something like a cache to store results so they can be served more quickly, or an index of documents. In addition to that stack existing, it exists not just once, but in multiple places. How do your folks do their local development? Is your development environment where people see this in development for the first time in a shared environment? Can that be replicated in testing, pre-production, and production? How do you manage your users within these environments? Who has the ability to manage other users? Who has the ability to create and delete and manage services within these environments? Or who just has read-only access? And on top of this, how are the operations managed day to day? Patching and vulnerability scanning, gathering and storing logs, scaling out to a content delivery network, and assuring high availability. This, frankly, at this point in time, in 2017, should be considered a commodity. Think your iPad or Android tablet. You largely self-service those systems. You don't go to the Genius Bar every time you need to update the Wi-Fi or get new software. They come with same defaults. They have vetted applications from a marketplace. They are regularly and continually patched, which you can deploy with a high degree of confidence. We have the bold notion that we can treat much of the underlying platform as a self-service commodity that is still performance and compliant. And what this enables then overall within the cloud.gov ecosystem is acquiring cloud.gov within weeks, get it running within hours, being able to build your service in a course of months, and see an authorization process that takes weeks. A little bit more about what cloud.gov is. Open source, built on Cloud Foundry, which is the same platform that is used by Pivotal, IBM, Monsanto, Ford. It's used widely in Japan, both in open source versions and in Pivotal's commercialized version. It's built atop Amazon Web Services GovCloud, which is it has a federal ATO through FedRAMP. It's available to departments and agencies by IAA. Cloud.gov has a moderate risk pre-authorization, equivalent to DISA level 2. And it's run by GSA Technology Transformation Services with staffing by 18F as a cost recoverable service. Now, when I say that we're using platform as a service, that means it's a pre-built environment ready to deploy your application, and your developers and engineers can focus on mission needs. And these resources underlying the platform are managed by a dedicated operations team, operating systems, databases, audit trails. So on the right side of the slide here, we have the typical breakdown of what denotes a platform as a service, infrastructure as a service, and data center with the various layers of infrastructure that need to support that. If you're in a physical data center, you're responsible for everything from the concrete pad on up. Fire suppression, power, cooling, the hardware, the racks, the servers, the cabling, the routers. And then the platform, what operating system are you running? How is it patched? What database services are you running, etc. And only then can you focus on the actual mission need of running the application. What we see a broad move towards in governments and in private industry in moving to the cloud is focus on infrastructure as a service and automation with infrastructure as code. And I came to federal service from Chef Software based out of Seattle, where we, along with Ansible and Puppet and others, provide automation software. And what I found over and over again was that focusing on infrastructure as a service and infrastructure as code is a great investment, but it often leads to relitigating the 30 years of decisions that went into how you built your data center in the first place. And so organizations get stuck there. Meanwhile, the project managers and the developers are saying, please, just give me an app server and a database and let us get to work. This is the problem that cloud.gov tries to solve by making it easy to get to launch. And there are 3 stages you need to get to, go through to actually launch. One is to procure your platform. You need to implement your application or customize a COTS off-the-shelf application, and then you need to get it authorized. And let's walk through the steps that are involved in doing that with cloud.gov. Procurement, well, we make things simple even before you procure anything, because agencies have the ability to get sandbox accounts before you've even procured anything. You can come into cloud.gov with your sandbox account, which we'll be using in the hands-on portion, run applications that have less than 1 gigabyte of memory, connect to the free database tiers and other services, and get to work. The IAA process, as Shashank mentioned, takes weeks instead of months. And then we have transparent pricing, which is essentially the risk that we're assuming modified by the complexity of the application. So a trivial application in a prototype package, $20,000 a year. A more complex application at a FISMA moderate, $110,000 a year. And here's a recapitulation of the chart that Shashank showed earlier. So that's procurement. Yeah.
Does that end up being per application, or does the one on the left, if you want to run more than one application, do the one on the left, can you then run more applications?
So the question was, does this pricing refer to one application? And it would refer to one system which may have multiple components. So when Will Slack introduces Federalist, you'll see that there are multiple, there are at least 2 web apps and several different worker tiers and storage. But since it is funded as one system, then it's priced out as a service, as one system. Yeah?
How do you talk at all about how you go from months of IA to weeks of IA, the actual process changes?
Oh, sorry, I should say when months is, or years is what it would take to do a full procurement in an open bid. And then our IAA process, on our side, it takes about 4 weeks because we've highly optimized every single step. Whether it takes longer than that on your side, that's on your side. So now let's get into the implementation. You need to make sure that you have users assigned to spaces or environments with particular roles. You want to work on your application, and you need services for those applications to store data or interconnect with each other. On the user side, users need to authenticate, and they need to have authorization to do certain things. The authentication can use either your agency's identity provider, as we've already set up for FDIC, GSA, EPA, and have in process for FEC. And then all of the authorization roles are stored within cloud.gov. And this is broken down into stock Cloud Foundry roles, where either you're a manager who can control other people's roles, a developer who can create and manage resources, or an auditor who has read-only access. Those can either apply to the entire organization, which would map to a project or program, or it can be mapped to just a single space, whether that's a development space or production space, for example. The breakdown is that an organization has multiple users with a permissions table. Within the organization, there are multiple spaces that users have roles within. And then a single space will have its own apps and services, and those are distinct from the applications and services running in other spaces. So you can call an application the same name in both spaces, and they won't interfere with each other. So this next slide is what you see when you go to Amazon and start to configure default roles for a member of your organization. There are hundreds of default roles and probably an infinite number once you start tuning them. Because we've built cloud.gov with sane and secure defaults on top of Cloud Foundry, the similar dashboard in our manager interface is simply a matrix of users and whether they're a manager, auditor, or developer. What this looks like on the command line, if you wanted to put commands into a text file to recreate your entire project someplace else, because we're going to be doing some of these commands in a few minutes, is we create, I as a manager create 3 different spaces: development, stage, and production. And then I assign particular roles to users. So Peter B is in development, gets to be a developer, but in the production space, I only get to be an auditor. What we've just done here is we've stepped onto a time machine. We have, in a matter of weeks potentially, procured a platform to run our application, and we have already implemented users with authentication that have roles in dev, test, and prod environments they can get to work. This is a process that I have seen take months when you're starting afresh with hardware or in infrastructure as a service, as you determine how do people connect, how do they authenticate, what do we build, how do we replicate those builds, how do we make sure people have access to the right things. And it can, once you're ready to go, take minutes with a platform as a service. Developers can get to work. Just as a quick example here, the 5 commands a Python developer would need to push a sample application, open it up in a web browser, see that it works, and scale it up to 4 copies. Speaking of Python, what languages and services are available in detail in cloud.gov? The languages that we fully support with what are called build packs are these 9: Java, Ruby, Node, Go, Python, and PHP, and .NET get the most use. The .NET is Microsoft's open source version with .NET Core 2.0. Has the potential to support a lot of Windows applications that we couldn't support natively before, so we're excited about that development. The code that you write in these languages then have a number of backend services that we provide natively in cloud.gov. Databases are through Amazon's relational database services. You support the 2 Postgres and MySQL, and have recently added support for Oracle. When you spin up Oracle, it is with AWS's, Amazon's pay-as-you-go licensing, so you don't have to worry about brokering a license deal with Oracle to start using it. The databases are configured to encrypt at rest, and you can only connect to them from within cloud.gov. Again, more of the same defaults architecture. Binary storage with Amazon S3, similar to Azure's Blob Store. You can host any domain in cloud.gov, and we also tie into the CloudFront Content Delivery Network, so you have all of your static content stored at edge nodes across the internet, so that you have very fast load times for your customers. We have Redis and Elasticsearch for providing data structure stores and full text search. And you can then tie back into cloud.gov authentication by providing provisioning a service for that. And you can provision service accounts if you want to tie in your releases to a continuous integration and continuous delivery system. Yeah, most of the pricing for cloud.gov is frankly around our overhead and staffing. And so we price that within the complexity, because we might have to bump some of those prices if you want to run the largest database size of Oracle, for example. The question was how do we price some of those services? And they're not pay-as-you-go. They are for us, but not for you. Operationally, we make sure that all the logs coming from your application are gathered, stored, and then available through an indexing system. You can also, we'll look at that during the hands-on portion. We can also stream them back to an on-premise log store if that's your preference. And you can connect, there are various ways to diagnose and your application if you want to track down any bugs, one of them being SSHing, getting a session onto the short-lived application containers. So that's the procurement and the implementation. How do you go about getting this authorized? And this is where the stack of paperwork comes in. Of course, we have the ATO process. And so your CIO needs to sign off on accepting the risk posed by your application, whether that's high, moderate, or low, depending on the damage of either the confidentiality, integrity, or availability of that application is compromised. Of course, we follow the controls laid down by NIST 853. What Shashank laid out earlier, well, let's look at, think about how those controls fall into different realms. If you're running a data center, you're going to be responsible for a moderate FISMA level application for all 325, including such things as who are your security guards, physical environment control 3, what's your process for wiping disks clean, media protection control 6. If you're using an IaaS service like Microsoft Azure or Amazon AWS, you inherit roughly 88 of those controls. You're still going to be responsible for 237, such as what happens to your system logs, audit control 12, how is kernel and operating system patching taken care of, system integrity control 2. The cloud.gov model for a simple application running within cloud.gov at a moderate FISMA level is that 269 of those are handled by cloud.gov, not just 88. There are 41 that are shared. Information spillage is one example. Another one would be audit 6, that there's an audit review and analysis process. So cloud.gov provides the built-in logging feature, but it's upon the customer to review and analyze their own logs. And then you would be fully responsible for 15 of those, such as verifying the credentials of the people who are working with you. This is what enables much faster ATOs. You have 15 controls that you're fully responsible for, and then the other 41 shared, and then 269 that you can inherit if your application domain has not changed the parameters on which you're being assessed. Plus, as we noted before, we provide simplicity and secure defaults. The S3 buckets we mentioned earlier, there are numerous ways to configure those if you have the full Amazon API at your disposal. But we should say either they're basic or they're basic public if you want to make assets available to people using your site. More broadly, we want to enhance compliance and security across the government by reducing the amount of shadow IT by enabling the self-service. So we have fewer servers in the closet, or today what people call credit card cloud. How much Azure or Amazon can you put on your P card? And then we take our responsibilities very seriously in terms of patching. An example is that in June, there was this potential kernel exploit in Linux called the stack clash. The standard is to patch those vulnerabilities within 30 days. We had it out, we have most patches like this out within 24 hours of release, and this one we had it out within 13 hours, which is largely the amount of time that it takes to rotate across all our machines. And that is done without any customer visible downtime because the containers move from machine to machine as they become available. So we've gotten through the 3 stages of procurement, implementation, and authorization. If there is something that you need for your IT system that's not yet in cloud.gov, it might very well be on our roadmap. Some of the things we're working on currently is tick ingress control, meaning that if your agency employees and contractors have to come through the VPN to get out to cloud services, we would validate that for a particular agency, they're only coming from the whitelisted addresses that are associated with your agency. We're going to work on enhancing our cloud.gov login to use PIV-CAC cards instead of just, in addition to, as an option instead of using tokens on your smartphone. The containers that are running in cloud.gov already have a lot of default permissions removed, but we're going to do scanning on top of that so if they start behaving in a way that's not in accordance with the profile, they would be flagged and terminated. Persistent file storage would provide network shared file storage if your application needs that for state. The ability, if you need to provision something outside of our standard provisioning service through AWS, and we want to provide a built-in CI/CD service. These are things that we're looking at in the next 1, 2, possibly 3 quarters for the CI/CD service as we figure out what to build and how. So let's step back to the mission, which wasn't just a supposition now, but is realized. You have your team that is able to get to work on a platform where they can build, test, and run, which is that everything that I've listed on this slide, the stack, the environments, the user management, and the operations are all included in what we provide with cloud.gov.